So now we are officially recording. So, bar there any outside interference or whatever, let's rock and roll. And anyone who just joined in, hi, it's Ian. We're just going to go over the exact same PowerPoint we did, and this will be recorded there on YouTube there. So come on in. So what we're talking about here, stoichiometry. This is what this is the end. All right, and we've been doing this there for the past 2 weeks, and it's all based on the chemical equation. A plus B produces C plus D, and based on the law of conservation of mass, we can't destroy. Every single atom has to be accounted for. So being able to predict, if I have 1 mole of this and 2 moles of this, how much in theory can I produce of C or D? And it all works together, and it's all about boxes. And I'm going to show you those boxes there today. All right, and this is review. There's a lot of the same questions here that, and I'd probably be here for 4 hours if we went through every single question, but we've been doing this there for the past couple weeks. What is the molar mass of aluminum chlorate? Okay, so being able to do this is paramount. It's so important. How many aluminums do I have? 1. How many chlorines do I have? 3. How many oxygens do I have? 9. Okay, and then the molar mass of one of these guys here, like 1 mole, the molar mass, so 1 mole of this, you go to the periodic table and you find the molar mass of each one, which is just the atomic mass unit, but this is in grams now. So 1 mole of aluminum is 26.98 grams. 3 chlorine times 35.45 is 106. Hello, hi, come on in. You didn't miss anything yet. There's 9 oxygens times 16. You add them up, you get 277.33. And you will notice here that, you see, I did all these there on paper, and then I snipped them and put them into the PowerPoint there to try and give you guys some guidance. But you'll see there that my number here is different than this number here. That'll happen because of using different periodic tables, okay? But you're going to choose A, B, C, or D, and let's say you get this answer, 277.33, and you'll be able to tell the correct answer, okay? There's not going to be another answer out there. There's only going to be one answer there that's logical to choose, okay? Normally in an in-class test, I would give you guys the formulas, but you guys will have the formulas right here. And just to recap, the 2 triangle formulas, you will have them there right beside you. Of course, you will. You'll be ready to go there for your test there next week. You've got to be able to be an expert at this. Okay. The number of moles is equal to grams divided by molar mass, or the number of grams is equal to the number of moles times molar mass. Even the molar mass is equal to grams divided by the number of moles. And it's interesting to note that you always have this. You always have this one. So I'm only ever going to be asking for this or this. Which means if I'm asking for grams, I have to give you the number of moles in some way. Okay. The next formula here. Okay. Triangle formula. You've seen this there before, where the number of moles is equal to the number of atoms or molecules divided by Avogadro's number. Okay. And please note, just like the previous triangle, you always have this one. Always. So if I'm gonna ask for this, then I have to give you this. And just it's interesting to note here that a student asked a question here. I think, what was it, was it the last quiz there? The total number of atoms total. Like, I'm just going to write on here. If I'm asking for the number of atoms of carbon, okay, that's an atom, okay? So this formula holds true. But I could also use this formula to find the number of molecules, okay, or formula units of this. So I can find out the number of atoms of a pure element, okay, and I would just use the same formula. All right. I could also find the, what's here? There's a molecule. This is an ion. This is an ionic solid. So this is we would call formula units, because ionic solids don't have aren't molecules. But I could ask you to find the number of molecules of HF, and I would use the exact same formula, the exact same methodology, but I would just use the number of molecules. Okay, and like, let's say I have my answer here. I found 10 atoms of carbon. Okay, that would be my answer. Then maybe for this one here, I asked for the number of formula units. I found 10 formula units. And this one here, maybe your answer, you would get 10 molecules of HF. And it's all using the same formula here. So I don't want you to get confused in all this. I could ask you for the number of atoms of carbon. I could ask you for the number of molecules of HF. I could ask you for the number of formula units of an ionic solid. So whenever you see formula units, it's just like molecules, but ionic solids don't have molecules. They're just formula units, okay? So those are the two formulas there. You will need the third formula, which is percentage yield, which is actual divided by theoretical times 100. So basically, you're only going to have 3 formulas that you're going to need there for this final test. Okay? And anyone who's just joined in, welcome, welcome, welcome. This is Ian. We are going over the Week 12 PowerPoint. And if you have any questions, let me know. I hope you guys are well and having some fun at least. One more week to go. Push it. Okay. So here we've got calculate the mass of 2.5 moles of aluminum chlorate. So how I want you to do these questions, because they're going to come at you like mashed potatoes on the test. You never know which one's going to be, yeah, I'm going to start you off slow and nice. But then on page 3 of the test, it's going to turn into mashed potatoes. You never know what's going to come next. So I want you to think like this. I want you to reboot every single question, okay? And you just finished a question. Now you're going to reboot. So calculate the mass of 2.5 moles of aluminum chlorate. So what is he asking for? He's looking for the mass. What's my only formula that has mass? That's right. You know which formula it is. So I'm going to have to use that formula. What information did he give me? He gave me moles. So just jumping back here, he's looking for grams. He gave me moles. I always have molar mass. Grams is equal to moles times molar mass. Away you go. Okay? That's how you do these ones. And I've given you how I did it right here. And again, you will see my written answer here is different than this answer here. I originally did these there, I don't know, 2 years ago. And I thought about changing it, making this answer 693.33, but I wanted to show you that depending upon the periodic table, you will get a different answer. But statistically, it's not different. And on a test, you will see 693 there. There will not be any discrepancy. Okay. Next question. Here, calculate the number of moles in 3.52 grams of aluminum. Reboot. What formula am I going to use? He's looking for moles. Wait a second. I have two formulas with moles. Oh, what information did he give me? Grams. Okay, so that tells me right there. He's looking for moles. He gave me grams. I always have this one. Moles is equal to grams divided by molar mass. Okay? And be careful on a calculator, depending upon your calculator, and this kind of scares me because I like having in-class tests because calculators suck and they don't care about you like I do. And if I don't want you guys to input or receive wrong information from the calculator. So just be careful. If you get an answer like this on your calculator, it's a good answer, but you might see this as one of the choices. Okay? And they mean the same thing. All right? And there's your decimal point. I'm kind of hovering below it. And we like that decimal point in between the first and second real number. So 1, 2. Okay. Now, is this number smaller or larger than 1? Well, this number is smaller than 1, so that exponent has to be negative. And we rounded 1.27 times 10 to the negative 2. Okay. Here's one here. Calculate the number of formula units. And I put molecules in here just to help you, all right? But here we're talking about an ionic solid. So that's why we call it formula units. Contained in 12.4 grams of aluminum chlorate. Okay, so what is Ian asking for? He's asking for the number of formula units. So he's asking for right here. He's asking for the number of molecules or formula units. So that's always here. So Ian has got to give me moles. But wait a second. Did I give you moles? No, you didn't. No, he didn't. What did I give you? Grams. So, which means you have to start off with the first triangle. Okay? I gave you grams. You always have the molar mass. Now, here you find the moles. And then you substitute it into here. Okay? That's one of those substitutions where you have to use two formulas to get the answer. Okay? And right here, going from grams to the number of units, and you see moles is equal to grams divided by molar mass. 12.4 grams given. Molar mass is 277.5, which we found a couple slides ago. There's your number of moles. Substitute that into the other formula to find your number of formula units. Okay? Some advice here for the test is, have some paper. Like, how this test is going to go is, I kind of like I'll probably put it on Blackboard. I don't know, I may just put the test up, have you download it, and you guys submit me the answers. By phone or take a picture of it or whatever. I don't know. I'll figure it all out. I haven't really thought about it yet. The test is ready to go, but it's delivery. Whatever it is, it's going to be open book at home in the comfort of your own home. So wear some comfy pajamas, get the coffee going. Make sure your calculator is ready to go. Pencils and paper because this is kind of math, right? With a chemistry aftertaste. What is this one here? What is the mass of 3.6 moles of calcium chloride? So I'm looking for mass. What formula am I using? What information did I give you? And you'll see here that this one here is easy peasy. Okay. How many moles of hydrochloric acid are contained in 18.2 grams of the compound? So asking for moles. Give you grams. There you go, easy peasy, away you go. And again, if you just joined in late, you'll see here that this answer here is 0.5 0.4988, which is, that's the answer that you might get in your calculator. And what are you going to do? You're going to look for the closest thing to 0.4988, which is, in this case, it isn't 1, it isn't 0.25, it's 0.5. Okay, so your answer here might be a little different. Guaranteed it'll be a little different. Okay, but there is only one choice. What do we got here? What is the mass of 1.6 times 10 to the 23 molecules? So what is he asking for? Mass. Okay, what formula? Okay, that's the first triangle. What information did he give me? He gave me molecules. So this is one of those ones there where you have to use the one formula to find moles, substitute into the other formula, and find your mass. And it's all right here. Here, number of moles is number of molecules divided by Avogadro's number. We get 0.2657. Okay, then we substitute that 0.2657 into the other formula, multiply by the molar mass, and we get this in grams. Okay. What is the percent of carbon in propanoic acid? So how do I do these percent? Okay. There's not really a formula for this, per se, not like percentage yield. This one here, it's basically what you're looking at divided by the total molar mass. So what is the percent carbon in propanoic acid? All right, so we're only looking at the carbon. How much carbon is there as a percentage of this whole thing? So first thing you got to do, you need to find the molar mass of this. So how many carbons? 1, 2, 3. How many hydrogens? 6. How many oxygens? 2. So you need to find the molar mass of propanoic acid, which is 74 grams per mole. Okay? Now, how many carbons are in here? Well, there are 3. So percentage composition is equal to the atoms or whatever you're looking for divided by the total. So it's 3 carbons divided by that. 3 carbons is 3 times 12. 12 is the molar mass, which is 36. And we found there that the molar mass of propanoic acid is 74. So 36 divided by 74 times 100 is 48.6%. Okay, so those ones there aren't too bad, I don't think. And again, there's no real formula. You can just have it right here. Okay, and hey, this is open book. If I were you, I would get everything all prepared. Every single question type, all your formulas together, periodic tables in order, everything is ready to go. And this is an exam question right here. Okay. Percent yield, actual divided by theoretical. And if it is expected to make 95 grams of a product and you only made 65 grams, what's your percentage yield? 65 divided by 95 times 100, so you only pulled in 68% of what you should have. Okay. Now we get into the stoichiometry. And it all has to do with ratios. That's all it is. All right. The stoichiometry expresses the quantitative relationship between reactants and products of a chemical equation. Okay. The equation must be balanced. Doesn't work if it's not balanced. So some of these questions here, I'll give them to you balanced. Some questions, you'll have to balance them before. Okay? And the whole point of this stoichiometry, it just allows us to predict certain values. That's all it is. Okay? And it's all based on a perfect being doing these. Okay? Every atom is accounted for. All right? And that's what these are all kind of theoretical stuff here. So, have a look here. And getting to the chemical equation, you'll see here that I got nitrogen and iodine and Ni3. first thing you do, you make sure this thing is balanced. So here I have 2 nitrogens over here. All right. And I have 2 nitrogens over here. Is good. Here I have the 6 iodines. Here I have 2 times 3 is 6. So this is balanced. Now, what I've been teaching you and you guys did there for your assignment 2, your molar ratios, 1, 3, and 2, right? And for your assignment 2 there, you guys were adding them up, and the answer here would be 6, right? And so 1, 3, 2, that's the molar ratio. If I doubled all of these, 1, 3, 2, and made 2, 6, 4, is it a wrong answer? No, it's not. Because just in the same way, I don't know if I can write that here, that 1/2 is equal to 2 over 4. They are the same thing. Half a pizza is still equal to 2 slices out of 4 slices. Same thing. But you know with mathematics, we like to have everything reduced down to its lowest terms. So when you're dealing, and plus it makes things a lot easier here when you're doing the mathematics. Okay, so we like to have things in their lowest terms. So getting into this right here. Calculate the number of moles of Ni3 that can be made from 2 moles of N2. So you see here, I'm looking for the number of moles of this guy that can be made from this guy here. I'm not even worried about this one. Okay, so you can just forget it. I'm just dealing with this guy and this guy. So the first thing you do, you see, I write it out, and if I do give it to you on a piece of paper there, I'll give you space to write it out, which I probably will do. I think it's easier there for you guys. And you'll have this written out. It's balanced. First thing you do, write your molar ratio, 1, 3, 2. Very first thing. Now, what is he asking for? What did he give me? Well, he's asking for the number of moles. What did he give me? He gave me 2 moles. And you see here, he's asking for moles. He gave me moles. These are moles up here. So it's moles, 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 mole to mole. Okay? These are the easiest. So here, what you do is you're going to do a box. And see, we're not worried about this one here. It's 1 to 2 over 2 over x. There's your box. 1 to 2, 2 to x. Cross multiply. So it's 1 times x is equal to x. 2 times 2 is equal to 4. So therefore now, if I had 2 moles of this, which is what the question is asking, how many moles of this can I make? Well, if I had 1 mole, like this guideline tells you, if I have 1 mole, I can make 2 moles. Well, if I have 2 moles, I can double it and make 4. So 2 moles of N2 can be made from 4 moles of Ni3. Or sorry, 2 moles of N2 can make 4 moles. Here's another mole. Calculate the number of moles of I2 required to completely react with 2 moles of N2. So here, same question there for simplicity. Balanced, there's your molar ratio. Here, if I have 2 moles of this, how many moles of this do I need for them to both go to 0? Right? And that's what here. Calculate the number of moles of I2 required to completely react. So as these two are mixing, if they're both going to go to 0 and everything is going to be on this side, how many moles of this do I need? Well, again, you see here, I'm asking for moles. I give you moles. It's 1 box. Bang, go. All right. And you see, these previous 2 examples, you know what I mean? Once you get good at these, you can kind of see it right off the bat. But sometimes you can't. The numbers there are, you know, I even have to do this. I couldn't sit here and figure this one out on my own because the numbers there are too close together. So here, calculate the number of moles of Ni3 that can be made from 5.5 moles of N2. Well, there's your molar ratio. It doesn't change. All of these don't change, the same steps. The chemical equation will change, but the steps do not. So how many moles of this can I make if I had 5.5? Well, set it all up, do your box, and away you go. Okay? Anyone who just joined in, don't worry you didn't miss anything. I'm going to post everything up on YouTube anyway. Okay? This whole thing, I'm recording this as we speak. Okay? Again, here's another mole. Okay? We do, it's exactly the same. If you see, you know, if I'm asking for moles and I give you moles, a mole is the easiest of them all. Okay? Let's see if I can move that up there. I don't know. Maybe I can. There we go. Good enough. All right. And here's another one. All right. How many moles of aluminum are needed to make 0.0935 moles of hydrogen? So, you've got your chemical equation, you write it all out, you do your molar ratio every single time. Now, are you going to use, there's 1 banana, 2 banana, 3 banana, 4. You're not going to use them all right? So, what am I asking for? How many moles of aluminum? So, X moles are needed to make 0.0935 moles of hydrogen. 0.0935 moles of hydrogen. Bang, 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 bang. Moles, easy peasy. Do your box. Next question. Okay? There's another one. All right, moles. Let's have a look here. Which of these statements is not true about the reaction? Okay, so it's the same reaction there we've been looking at. And which one is not true? A, 1 mole of nitrogen is needed for 3 moles of iodine. Well, it's 1 to 3. Talking moles? Yes. 1 gram of nitrogen is needed for every 3 grams of iodine? No. Molar ratio is 1:3:2. Not grams. All right? Moles. So that's your answer right here. C, 3 moles of iodine can produce 2 moles of Ni3. 3 moles of iodine can produce 2 moles. Yes. Okay. What do we got here now? How many moles of HF will be produced by the complete reaction of 1.42 moles of H2? So again, you will be able to see this there. What am I asking for? Moles. What did I give you? Moles. This means 1 box. This is the easiest of the stoichiometry. Okay? So there's my formula. Molar ratio. Asking for moles. I give you moles. 1 box. Next question. Okay? Again, same thing. Lots of examples here. How many moles of H2 are made by the reaction of 1.5 moles of hydrochloric acid with excess aluminum? Now, don't be afraid of this word. Okay? Do everything there the same. There's your chemical equation. It's balanced. There's your molar ratio. What am I asking for? How many moles of H2? X moles. What did I give you? 1.5 moles of HCl and excess aluminum. All that means is here I have way too much of this, which means that this one is going to go to 0. We're going to run out of this. Okay, this one here is in fact my limiting reagent. This is the one that is going to stop the reaction because we're going to run out of it. This one here I have too much. So anyway, I give you moles. I'm asking for moles. 1 box. There you go. That's all these are. Now, How many moles of carbon dioxide are produced when 3 moles of oxygen react completely? Same banana. Same thing. Okay? You do your molar ratio. What am I asking for? What did I give you? Moles to mole, 1 box. Now, what we just covered there, all those stoichiometry questions, I'm asking for moles, and I give you moles. Easy. If I give you moles, how many moles can you make? That's what we just did right there. That mole stuff there, the previous, 7 or 8 slides there, that's 1 box. All right? Now, what I can do, instead of giving you moles, I could give you grams. Instead of giving you moles, I could give you the number of atoms or molecules. Before you do anything, you have to convert either this one or this one, both of them. You've got to change them into moles. And then you do your box. Okay? So it's exactly the same as what we've been doing, but I just didn't give it to you in moles. So before you do any calculation, if I give you something in grams, you got to convert it to moles and then go forward. If I give you something in number of atoms or molecules, you got to convert it to moles and then go forward. Okay? It works the same on the flip side. Like we were doing mole. So I was asking for moles and I was giving you moles. Easy peasy. But now I could ask for this answer in grams. Or I could ask for this answer in the number of atoms or molecules. Okay? So you're going to do your 1 box. You're going to get your answer in moles. Go back to the question. Did I ask for the number of atoms? Did I ask for the number of grams? Okay? So let's try this out here. How many moles of propane are consumed when 1.81 times 10 to the 23 molecules of carbon dioxide are produced in the following equation? So, same thing. Write out your chemical equation. There it is. Write out your molar ratio. 1, 5, 3, 9. Everything is balanced. There you go. What am I asking for? How many moles of propane? X. What did I give you? 1.81 times 10 to the 23 molecules. Okay. You see, it's the same setup every single time. But this time here, you can't do a box yet because that's in moles, that's in moles, that's in moles, and that is in the molecule, eh? So you can't do anything with that. You need to convert this to number of moles. How do you do that? Use one of your triangle formulas, and you know which one to use. Okay? So a number of moles is equal to number of atoms divided by avocado's number, 1.81 times 10 to the 23 divided by 6.02 times 10 to the 23 gives you 0.300 moles. Now you bring that over here. Now, and you see I circle these so I don't lose track, right? 1, 2, 3, 4. Do your box. You're done. Okay? So this is just stating there the exact same thing as what we just did. Okay? And you see now things have kind of changed. The easy ones there are mole. But here, mole to mass. So here, what mass of hydrogen gas is made by the reaction of 3 moles of hydrochloric acid with excess aluminum? Okay, set it up. Molar ratios. What am I asking for? X grams. And I write it right in there. And information you gave me, 3 moles of HCl. Okay, so moles, moles, moles. I can find out the number of moles of this. Is that what the question is asking for? No. but I need to find the number of moles first. So then you do your box, you find the number of moles, which is 1.5. All right, 1.5 goes there. But now you have to convert that to the number of grams. And what formula do you use? You use the first triangle formula. Number of grams is equal to moles times molar mass, which is right here. Grams is equal to moles times molar mass. We found 1.5, and the molar mass of H2 is 2, right? Hydrogen 1, and it gives us an answer of 3 grams. Okay? Mass to moles, same thing. Like we're just kind of running over the same ground here. All right? Everything here has to do with one box. All right? I'm asking for, in this case here, how many moles of HCl are needed to completely consume 2 grams? Well, there's your chemical equation, your molar ratio. What am I asking for? Number of moles. What did I give you? Grammage. It's no good. I need to convert this 2 grams, okay, into moles. Okay, 2 grams divided by 26.98 gives me 0.074 moles. Sub it back in, do your box, away you go. Okay? There's another one. Same thing. All right? And every one of these, you do the same thing. Here's your chemical equation, your molar ratio. What did I give you? What am I asking for? One box. You may have to convert first and then do a box. You may do a box first and then convert, but that's how she goes. There's another one, mass to mole, and the steps are all in there. I hope these aren't too bad. I hope these aren't too bad. It's just a lot better if I'm there with you in front of the chalkboard. But how many moles of oxygen are consumed when 38 grams of aluminum oxide are produced? Same thing. Okay, there's your chemical equation, your molar ratio. What am I asking for? Moles. What did I give you? 38 grams. No good. Convert that to moles, which is 3725 moles. Do your box. Find your answer. I want to skip to mass. Now, these ones here, out of aside from the limiting reagent, which we'll do in a little bit, a couple minutes, these ones here are the pain in the butt. They are, because to go back schematically, you see, the easy ones here are mole. What we've just been doing there been mass mole, or molecule mole, or mole to mass, or mole to molecule. All right, but these last ones here, mass. So I'm going to give you grams of this and ask you to find grams of this. So basically, you've got to convert grams to moles, then do your box, and then you've got another conversion at the end. So these ones here, you're going to have 2 conversions, and in the middle, you're going to do your box. So, I have no idea what slide that was now. Sure, sounds good. So, you have a look here. What mass of bromine, which is under 59.8 grams per mole, that's a molar mass, is needed to completely consume 7 grams of aluminum? So, write it out. Even if this seems like Latin, it's not even making any sense. You're going to do this the exact same way every single time. You write out your chemical equation. 2 aluminum plus 3 bromine, 2 produces 2AlBr3. You get your molar ratios going, 2, 3, 2. What am I asking for? What mass of Br2? So X grams. What information did I give you? 7 grams of aluminum. 7 grams of aluminum here. So, you may be tempted to do a box. Don't. Because this is in grams, moles, grams. Okay? This one here, you have to convert to moles, which I've done right here. Okay? Which is 0.2592 moles. Then you do a box. 0.259, 2, 3, and that gives you 0.3888 moles. The answer is looking for grams, so therefore now you have to do that second conversion. So if I give you grams and I'm asking for grams, all right, you can grit your teeth and know that there's going to be a little bit of work involved here. Like, am I going to jam-pack the exam with these? No. You might get 2. You might even get 1. Because they're going to take you 5 minutes. Like this one here wasn't too bad because in the question I gave you the molar mass. But maybe in... Hey, what happened there? But on a test situation, you may have to go to your periodic table and go, what's the molar mass of Br2? Well, bromine there is what, 70, I don't know, whatever, 7, I don't have it memorized. But, and you'd have to know that there's 2. All right, so that is the molar mass of a bromine molecule. All right, so there is a little bit of work involved. And maybe I oversimplified it, but converting here the number of grams into moles, you'd use number of moles. It's your triangle formula. That'll give you your number of moles. Then you do a box. And then here, I'm asking for grams. You have to use your formula again to convert back into grams. Okay? And anyone there who came late, you'll notice there that my answer of 62.13 is different than my answer here of 62.08 because I probably used a different periodic table there when I did the original PowerPoint there 2 years ago. Don't worry, you're going to see whatever your answer is. If it's correct, you're going to see that answer there. You might be off by, small amount, but there's only going to be one real answer. Okay? What do we got here? What mass of oxygen is consumed when 54 grams of water is produced? So here, I'm asking for grams. I give you grams. This one here is a pain in the butt. You got to set it all up, convert it to moles, then do a box. You get your answer, convert that into grams. So hopefully these aren't too bad. I wanted to get into this right here. Slideshow. Yeah. When we get into the limiting reagent, some of these slides here, I don't know, they're probably not so good, but looking at here, I have, here's my chemical equation. I have 2 of these plus 1 of these produces 1 of these. So what is my molar ratio? 2, 1, 1. So I need twice as many of these than these to make these, right? So let's have a look here. And you'll see there's 1, and there's 2, and then there's 3. And you see there, we have some left over. And what we're talking about here now is we ran out of this. We still have excess. Remember that there from previous. We still have excess here. We have too much of this. We ran out of this guy here. So this one here is our limiting reactant. And you see the reaction stopped. Okay, the limiting reactant is the one we have the least of. I'm going to go back to this form here. So this one here was the excess, what we have left over, and this one here is this one here was our limiting reagent. So this one here, if you add them all up here, I need 2 wheels, I need pedals and all this kind of stuff here, and as it turns out, we didn't have enough of the pedals. So in this case here, the pedals were the limiting reactant. These ones here, now the ones we were just doing there, mole, mass, mass, you were only doing one box because I was asking for one bit of information and I was giving you one bit of information. Again, because on the test there, these are all going to be mashed potatoes. You never know which question is going to come. So every single question you're going to reboot. Okay. All right. All those previous stoichiometry we were doing, I was asking for one bit of information, whether it be mole or gram or whatever, and I was giving you only one bit of information. Maybe it was mole, maybe it was mass, maybe it was number of molecule, but that's it. So if I'm asking for one bit of information and I only give you one bit of information, you're only going to do one box. Have a look. Now, calculate the number of moles of water that can be made by the reaction of 2 moles of hydrogen and 1 mole of oxygen. So, set it up the same way. So there's your chemical reaction. There is your molar ratio, 2:1:2. But wait a second. He's asking for one bit of information. Calculate the number of moles of water. So there's my X. Everything's the same so far. But yet now he's giving me 2 bits of information. This signifies a difference from the previous questions. Okay? Because here I've given you 2 bits of information. Alright? Not 1. So, how are we going to do this here? What we're going to do now is we have to determine which one we're going to run out of first. So, this is my theoretical molar ratio right here. This is my experimental. This is what I'm giving you. So if I give you 2 moles of hydrogen, and if I give you 1 mole of oxygen, how much of this am I going to make? Well, you have a look here. I need 2 moles of this to react with 1 mole of this, so these are both going to go to 0 at the same time. Well, I've given you the exact same number, so both of these are going to go to 0 at the same time. We were not going to have any excess. We're not going to have a limiting reagent. Okay, so the answer would be 2. Now this one here is oversimplified just to show you that there is no limiting reactant in this situation. Let's have a look at this one. Same formula, same chemical reaction. Calculate the number of moles of water that can be made by the reaction of 1 mole of hydrogen and 1 mole of oxygen. So, same thing. You're going to set this up. There's your molar ratio. What am I asking for? Number of moles of water. What information did I give you? I gave you 1 mole and 1 mole. Okay, he gave me 2 bits of information here. This is not like before. Now, if we go back to our theoretical here, 2 moles of this will react with 1 mole of this, and they'll both go to 0 at the same time. They'll both react at the same time, and they'll both shut down because they both run out at the same time. But have a look here. I give you 1 mole of this and 1 mole of this. Which one am I going to run out of first? Well, if I need 2 moles of this to react with 1 mole of this, I've only got 1 mole of this now to react with 1 mole of this. So hopefully there that you can see that this one here you're going to run out of first. Because according to the molar ratio I need 2 to fully react with 1 mole. So the reaction will run out of H2 before of oxygen runs out. H2 will be the limiting reactant. The reaction will stop. Okay, and so what we're going to do is you do a box, and you'll find there that I have the. I'll show you there the methodology here, but you do a box 1, 2, 2, X. Do your box. Because this one is the limiting reactant, that is the information you use. Because the limiting reactant stops the equation or stops the reaction, so that is the number there that you're dealing with. So, and you do your box and you get an answer of 1 mole. And that kind of makes sense. If I need 2 moles of this to make 2 moles of this, well, if I only give you 1 mole, it has to be the same number. And how I set these up, like some of these are not going to be this easy. You can't really tell. Some of them you can, some of them you can't. So this is how I do it, and this is how I've shown my students here. Calculate the number of moles of water that can be made from 1 and 1. So this is exactly the same question. Now, I'm just going to cancel these out for right now. So, I write out my chemical equation. There's my molar ratio. And how do I know that this is different than the previous stoichiometry? Because Ian gave you 2 bits of information. He's asking for the number of moles of water, okay? But he gave you 2 bits of information. That's how you know this is different. So therefore, when you see 2 bits of information, I go scenario 1, scenario 2. Because we have to determine which one is the limiting reactant. So if you write scenario 1, scenario 2, and you see how I kind of put, I don't know, little walls here. Nothing for the arrow, that's just blacked off. And then I have my X here, I have these guys here to determine how much. This is what we want to find out. And the information I gave you, that one, the information there for hydrogen goes here. The information there for oxygen goes here. And I've designated these a different color. You can do whatever you want. You can put circles or whatever. But these are the experimental values. This is what I gave you. Now, why do I have to do scenario 1 and scenario 2? Well, what we're going to do is you're going to do 3 boxes. So limiting reactant with 2 bits of information, you're going to have to do 3 boxes in order to answer this question. The previous stoichiometry there, you only had to do 1. These ones here, you're going to have to do 3. So, I gave you 1 mole of this. In order for this to go to 0, how many moles of this do I need? So I've got box number 1, 1, 2, 1, X. See? Right here, right here, right here, and I put an X. Alright? And if you do a box there, you'll find out that that number is 0.05 moles. Okay? Now, a good question. These guys are in yellow. These numbers here aren't real yet. In order for this one here to go to 0, how much do I need of this to go to 0? Well, if this is going to go to 0, I have to have 0.05 moles. Do I have 0.05 moles in real life? I do. So this reaction could possibly go on. But just to be on the safe side, I need to know if this one here is the limiting reactant. So I need to do another box. Right here. And if this one here is going to go to 0, how much of this do I need? Well, you do your box, and you'll see there that you need 2 moles of hydrogen in order to make 1 mole of oxygen go to 0. Ask yourself, do I have 2 moles in real life? No, I don't. So that means that this one here is a false statement. I'm just trying to black it out. I don't know why it won't let me. There we go. So that one there is a false statement. All right? That's why we do limiting reactant. So we're not using these numbers anymore. We are going to use these numbers here. Now let's go back to the question. Calculate the number of moles of water. So here I'm looking for X moles of water. I can do a box. Now I can use this box to find the answer, or I can even use this box to find the answer. Doesn't matter, they're both going to work. You've solved the riddle, that's what it all is. And if you do either box, you get an answer there that 1 mole. Okay, you get 1 mole here, all right? And that's the limiting reagent. That's how you do these ones, all right? How many boxes did you do? 3. Why? How do you recognize these from the previous stoichiometry questions? I've given you 2 bits of information. All right. There, and this is how I set it all up. There's my chemical equation. There's my molar ratio. What information am I asking for? I'm looking for X moles. What information did I give you? Well, I gave you 1 and 1. Scenario 1, scenario 2. You do box number 1, do box number 2, cancel the false statement, go forward with this one here, and then do box number 3. That's how you do this there in pen and paper. Again, calculating the number of moles of water that can be made from the reaction of 3.4 moles of hydrogen with 1.75 moles of oxygen. Ding, ding, ding. There's a limiting reagent. That's how you tell. Set it all up the same way. Okay. And I think I've done it right here. And you see here, set it all up the same way. Scenario 1, I gave you this and I gave you this. You need to figure out which one is your limiting reagent. Okay. Which means you're going to do box number 1 to get this answer. Box number 2 to get this answer. Figure out which is a false statement. Here you found that if 3.40 moles is going to go to 0, how much of this do I need? 1.7 moles. Do I have it? I do. If this one here is going to go to 0, we need to do box number 2 to find 3.5 moles. Okay. Do I have 3.5 moles? No, I do not. Bogus. It's gone. And now we use either of this information there to find this information here, box number 3. Okay? There's another one right there. You can try this out. It's exactly the same thing. Okay? And practice these. The only way to do these, this is mathematics, the only way to do these is to just walk on the same carpet again and again and again. And that's why it's kind of nice there that you've had this information there for a couple weeks now. And I've been kind of preparing you guys this ever since like week 8 with your molar ratios and all that kind of stuff. So do you guys have any questions for me? And I just want to say that I'm proud of you guys. You guys are an awesome class. And I'm going to be taking the summer off. There's just so much work that needs to be done here around the house. But I will be in contact there. I'm going to be on email there for the next couple weeks anyway. So please don't hesitate to contact me any time of day, anytime at all. And sorry, Ramis, did you have a question? I don't know if you guys can you guys can talk. I think I had a class there yesterday. Hello.
Hello, can you hear me?
Oh, there we go.
I'm just wondering how many questions will be examined, and do we have a time limit?
Yeah, there will be a time limit. Like I've been your quizzes. They are what they are because the content is going to be exactly the same. The test is going to be multiple choice. So I'm preparing you guys for this by getting you guys to do your quizzes and all that kind of stuff there. There will be a time limit. I know the quizzes I give you a couple days to do. It's all good in the hood. What I'm thinking is you'll have lots of time. I'm thinking maybe 60 questions, 50 questions, 70, somewhere in there, that range. You'll have lots of time. You'll either be able to, it'll be on Blackboard where you just do one question after another, and you'll be able to stop the test, go to McDonald's, come back, and start it up again. Will you have 3 days to do it? No. Probably be in the range of, I don't know yet. Or what I'll do is I'll give you the test PDF style. You can do the test and then hand it back to me, the answer sheet, I don't know, in 6 hours, 8 hours, I don't know. We'll work it all out, but that's where we're at. Good question. What else you guys got? How is everything going? Is this stuff horrible, or does it kind of make any sense? Is it coming? Talk to me.
Hi, Ian.
Hi.
What day will our test be?
It'll be next Friday, I guess. And sorry about there. I guess I forgot there that this Friday was Good Friday. And I'm thinking there it'll be next Friday. Is that cool?
Good for me, thank you.
All right, very good, very good. I hope this stuff is going all right. It's not the easiest, and Jesus Murphy, man, I can't even imagine teaching this stuff over the internet. You guys are kind of left to your own devices, but hopefully they're like this video right here. I'm recording it, and as soon as I record it, it's going up on YouTube. And so you guys can have it. You can watch it anytime you want. Stop it and start it. Practice these. Basically for the test, it's everything we've done since week 8. Chemical reactions, balancing, all these kinds of things. But really, you're going to have to name, like if I say to you, what's the molar mass of calcium chlorate? Well, you got to know calcium, and then you got to find chlorate as a polyatomic ion, oxidation numbers, this crisscross, find your chemical formula, and away you go. So everything that we've done since probably week 4. And but I'm proud of you guys. You guys are doing great. Keep asking questions. I check my email 10 times a day. So if I miss you on one night, I get you there in the morning. So keep asking questions. You're doing great. Keep fighting. And I'm shocked there that I'm taking the summer off, and I'm not going to probably see some of you guys ever again. But I want you guys to know that just because you guys aren't my students, you always will be. I have students there at Guelph and York there that still bother me and hassle me from time to time, and I love it. And if you're gone after the summer and you're off to another school there for paramedic or nursing or whatever, please know that take down my email. I have access to resources that you don't, and I like to know there that you guys are doing well and on the way to prosperity, because you guys are the future. So I got nothing more. If you guys have any questions, let me know. Other than that, I'm good to go, and I'll be in contact there this weekend there about what's coming up there for next week. And I think your assignment 3 is due on Monday or something. So, no, Tyler, it's all good. It's all good. You guys just be safe out there. Please, when you're washing your hands, sing a song for 20 seconds. All right? And just take care of yourself and be safe. And Godspeed to your dreams. And if you need anything now, even in 10 years from now, you just get a hold of me and we'll get her done. It's all good, Jacqueline. Thank you very much. Okay, guys. If you guys got nothing else, you guys take it easy. Yeah, cheers. Thank you. Alright, now how do I stop this thing here?